Hello everyone, this is Professor He again. Nice to see you all. The topic of this task is about the pressure of a system. Pressure is defined as the normal force exerted by a fluid per unit area. Normally, we speak of pressure when we deal with a gas or a liquid. The counterpart of pressure in solids is normal stress. Note, however, that pressure is a scalar quantity while stress is a tensor. Since pressure is defined as force per unit area, it has the unit of newtons per square meter, which is called a Pascal. The pressure unit Pascal is too small for most pressures encountered in practice. Therefore, its multiples kilopascal and megapascal are commonly used. Three other pressure units commonly used in practice, especially in Europe, are bar, standard atmosphere, and kilogram force per square centimeter. Most pressure measuring devices, however, are calibrated to read zero in the atmosphere, and so they indicate the difference between the absolute pressure and the local atmospheric pressure. Pressure is also used on solid surfaces as synonymous with normal stress, which is a force acting perpendicular to the surface per unit area. For example, a 136 kilogram person with a total foot imprint area of 300 square centimeter exerts a pressure of 0.46 kilogram force per square centimeter on the floor. If the person stands on 1 foot, the pressure doubles. If the person gains excessive weight, he or she is likely to encounter foot discomfort because of the increased pressure on the foot. This also explains how a person can walk on fresh snow without sinking by wearing large snowshoes, and how a person cuts with little effort when using a sharp knife. The actual pressure at a given position is called the absolute pressure, and it is measured relatively to absolute vacuum. Most pressure measuring devices, however, are calibrated to read zero in the atmosphere, and so they indicate the difference between the absolute pressure and the local atmospheric pressure. This difference between the absolute pressure and the local atmospheric pressure is called the gauge pressure, P gauge, which can be positive or negative. Pressures below atmospheric pressure are sometimes called vacuum pressures and are measured by vacuum gauges that indicate the difference between the atmospheric pressure and the absolute pressure. The relationships between the pressures are the focus of our topic. The gauge pressure is the difference of the absolute pressure and the local atmospheric pressure, while the vacuum is the difference of the local atmospheric pressure and the absolute pressure. Throughout this course, the pressure P will denote absolute pressure unless specified otherwise. The topic of this subtask is about the manometer. An elevation change in a fluid at rest corresponds to this value, which suggests that a fluid column can be used to measure pressure differences. It is commonly used to measure small and moderate pressure differences. A manometer contains one or more fluids such as mercury, water, alcohol, or oil. In stacked-up fluid layers, the pressure change across a fluid layer of density ρ and heat H is ρgh. The pressure at point 1 can be easily expressed as the pressure drop across a flow section or a flow device can be measured by a differential manometer. A relation for the pressure difference P1 minus P2 can be obtained by starting at point 1 with P1, moving along the tube by adding or subtracting the ρgh terms until we reach point 2 and setting the result equal to P2. The manometer shown in figure that is used to measure the pressure in the tank. Since the gravitational effects of gases are negligible, the pressure anywhere in the tank and at position 1 has the same value. Now, let's have a look at something relevant but a bit different. The topic of this subtask is about the barometer and the atmospheric pressure. Atmospheric pressure is measured by a device called a barometer. Thus, the atmospheric pressure is often referred to as the barometric pressure. A frequently used pressure unit is the standard atmosphere, which is defined as the pressure produced by a column of mercury 760 mm in heat at 0 degrees centigrade under standard gravitational acceleration. The Italian Evangelista Torricelli was the first to conclusively prove that the atmospheric pressure can be measured by inverting a mercury-filled tube into a mercury container that is open to the atmosphere, as shown in figure. The pressure at point B is equal to the atmospheric pressure, and the pressure at point C can be taken to be 0, since there is only mercury vapor above point C, and the pressure is very low relative to P80M and can be linked to an excellent approximation. If water instead of mercury were used to measure the standard atmospheric pressure, a water column of about 10.3 meters would be needed. Pressure is sometimes expressed in terms of the heat of mercury column. The standard atmospheric pressure, for example, is 760 millimeter mercury and 0 degree centigrade. The unit mmHg is also called the torr in honor of Torricelli. The length or the cross-section area of the tube has no effect on the heat of the fluid column of a barometer, provided that the tube diameter is not enough to avoid surface tension effects. This means the length and the cross-sectional area of the tube have no effect on the heat of the fluid column of barometer with a not enough tube diameter. Okay, that's all for this task. Thank you very much and see you next time.